Hello and welcome to AGI's GeoWebinar series. My name is Leila Gonzalez and I'll be moderating today's GeoConnection Webinar Roundtable, A Secure Future for Energy, Environment, and Hazard Mitigation, retaining students through the Student-to-Professional Continuum in the Geosciences. I'd like to acknowledge our co-sponsors and thank them for promoting this webinar roundtable to the geoscience community, the Soil Science Society of America, the YES Network U.S. National Chapter, and the Australian Institute of Geoscientists. Now today we'll start off with a brief look at some national data pertaining to student retention in geoscience university programs and student transitions into geoscience occupations. Then we'll break into Skype chat-based working groups to discuss the questions that this roundtable is about, which is one, how do we successfully retain geoscience students in U.S. university programs? And two, how do we successfully transition geoscience graduates into geoscience occupations? Both working groups will be discussing the same set of questions, and our working group moderators are myself and Maureen Moses from the American Meteorological Society, and she's also a member of the YES Network's U.S. National Chapter. Maureen will be moderating the working group number 1, and I'll be moderating the working group number 2. The text highlighted in blue here is the Skype contact name that you will need to add to your Skype contact list to join this discussion group. So go ahead and do that now. Go ahead and pick a working group and add that Skype contact name to your Skype application, and then we'll go ahead and start accepting those throughout so that we can start the discussions when the time comes. We'll have about 30 minutes to discuss these questions, and then we'll reconvene here on the webinar page to listen to Maureen and I give the summaries of our working group discussions. Now, and then we'll wrap up there. Now, just to give you a graphical explanation of how this is going to work. Right now we're here on our webinar panel. We're going to listen to the presentation shortly, and then after that we'll go ahead and minimize that webinar panel. We'll maximize the Skype chat window, and again choose your working group, either number 1 or number 2, and then we'll go ahead and come back over to our presentations at the very end here. Okay? So now, just to get started, we're going to look briefly at national trends along the student-to-professional continuum, including student preparedness for university-level geoscience programs and student retention at the undergraduate level. And then we'll turn our focus over to career trajectories of geoscience graduates and finish up with a look at current demographics and future employment projections. Now, our first stop along this continuum is the high school senior to undergraduate transition. One of the things we want to look at is how prepared are students for geoscience curricula, students that are coming out of high school, entering into university. The College Board SAT test results indicates that 47% of high school seniors have had some experience or coursework in earth science. The charts here at the bottom, they show the mean SAT scores from 2006 through 2009 of high school seniors who've had coursework or experience in different science cohorts. The gray bars here are the mean SAT scores for all test takers, and then the colored bars represent different science cohorts. As you can see, those with coursework in earth science scores, coursework within earth sciences score not only below other science cohorts, but also below the national average. And now that's for critical reading and mean writing SAT scores, but also the same holds true for mathematics. Now let's take a look at university enrollments. Since 1995, undergraduate enrollments have hovered around 21,000 a year, and graduate enrollments around 9,000 per year in geoscience programs here in the U.S. Now, if we look at take a closer look at the undergraduate enrollment profile, which this data on the left here is based on historical data that AGI has collected in previous enrollment surveys. This undergraduate enrollment profile really shows where the attrition is occurring, as noted by the blue arrows. Those are students exiting. Note that most departments don't recognize majors until they're in their sophomore year. As such, the enrollments are not capturing those freshmen who enter and exit the geosciences but never make it to the point where they're included in their departments reporting about their enrollments. So they would be considered here in this gray circle. Okay. Furthermore, so our data here then is only capturing about 2.5 years of enrollments. So if we consider the sophomores here as our peak of enrollments, what we see here is that we lose nearly 44% of enrolled undergraduates by the time that they reach their senior year. Now, if we look at graduation rates, we see that from the senior year to graduation, we're looking at about a 58% graduation rate. From sophomore year to graduation, we're looking at about a 33% graduation rate. But if we look at completion rates from freshman to degree, that's going to be much lower. And bulk attrition is always much lower than graduation rates, and in fact, the STEM-wide completion rates average around 25%. Now, data that we've seen indicates that about 50% of freshmen exit university before their sophomore year. So then if we use this estimate and we back calculate from our sophomore numbers, we come up with about a 16% completion rate for geoscience undergraduates based on these average enrollments in degrees since 1995. Now that percentage is going to vary on a year-to-year basis, but that gives us a benchmark to kind of keep in mind as we move forward looking at this. Now, for undergraduate students who do make it through to graduation, about 28% of them go on to graduate school. Now, that's about 800 students, which is about half of our first-year graduate student enrollments. Data we analyzed from NSF CSTAT database indicates that approximately half of new geoscience graduate students have a bachelor's degree in a non-geoscience field, the other half in geoscience. Of the nearly 9,000 geoscience students enrolled in graduate programs, we graduate on average around 1,064 masters a year and 647 doctorates per year, and that's an average since 1995. One thing that's hard to capture in these numbers is trying to get more information about those master's graduates who started out with their first intention as a master's degree, so they entered in the master's track, versus those that entered in the PhD track but exited as a master's student. Now let's take a step forward and let's take a look at student graduate to professional and look at that continuum. Again, data we gathered from the NSF CSTAT database indicates that about 35% of all geoscience graduates for all degree levels enter geoscience careers. Now, by degree level, we're looking at bachelor's. 30% of bachelors would be moving on to those geoscience careers, masters at 43%, doctorates at 66%. And at the master's level and below, even though the majority are not moving into those geoscience careers, definitely the majority of geoscience graduates do stay within science and engineering disciplines. With these percentages, we're looking at about 850 undergraduates and 880 graduates entering core geoscience occupations per year. And that's not enough to keep up with existing and future demand in geoscience workforce jobs. What we're looking at here is recent data from the Bureau of Labor Statistics on their employment projections. If you pull together all of the geoscience occupations, we see a 23% increase in the number of geoscience jobs between 2008 and 2018. That's about 60,000 new jobs. Now, this calculation does not factor in attrition from retirements of the current workforce. And currently, the majority of the geoscientists in the workforce are now within 10 to 15 years of retirement age. As an example, this graph here on the right, what we're seeing here is a chart showing age demographics of geologists in the U.S. government. And this age demographic curve is not unique to just the government, and we're also seeing this curve in industry as well. And in the long term, the wave of retirements coupled with a low number of new graduates entering the geoscience profession means that we'll be seeing a loss of mentors for those new entrants, a loss of technical expertise, and also a loss of institutional knowledge. And we're already starting to see the loss of fundamental technical skills in the geoscience workforce, both within academia and in the applied sectors. And given the current trends, many core and specialty geoscience subdisciplines that are also economically critical are at risk of extinction. Without properly targeted investment in the retention of geoscience university students and the successful transition of those geoscience graduates into those geoscience occupations, we're looking at threats to sustainability of geoscience academic infrastructure in the U.S. and pursuit of basic geosciences research. So that's an overview, it's kind of fast, of where we are and what we're looking at both in the retention and transition of students from geoscience programs into the workforce. So as we move forward now into our working groups, I want us to go ahead and take a look at these two questions. One, how do we successfully retain geoscience students in university programs? And two, how do we successfully transition geoscience graduates into geoscience occupations? I'm going to go ahead and put the working group discussion questions up here as well as the Skype chat contact names. So go ahead and add those, choose your working group, add it to your Skype, and then we're going to go ahead and transition over to that now. Welcome back, everyone. Hope you all had good discussions in your working groups. I know in our working group number 2, we had great discussions, so it's good to have everyone back, and thanks all for the insights and all the thoughts. Some really good discussions. Well, what we're going to do now is we're going to go ahead and hear the summaries from working group discussion number 1. Maureen Moses is moderating that discussion group, so I'm going to go ahead and turn this over to Maureen so she can give us a summary of what they discussed. Maureen, when you're ready, go ahead.
All right, thank you. I believe we had a wonderful discussion. In terms of education, one of the main things that we discussed was the diverse pathways to find a geoscience major, and that created a large age distribution, and maybe a reason that the professors in our group felt that the experience of teaching was contradictory to the data shown in the previous discussion. As for workforce, we had a very strong conversation. There are 2 groups of people in our group, or in our discussion, and there were students as well as teaching professors and one industry representative who was a translator. And the student experience sounded a little bit discouraging at times. They felt that when they looked at resumes available that they were unclear as to what materials were, or they were unclear how to match what they learned in their courses to what the needs were of the employer, and they noticed a disconnect. And the professors all mentioned that the pace of industry is much faster than that at academia, and so they're feeling discouraged in terms of meeting the needs of those students. One of the strategies presented was to really encourage strong leadership at the department level, where people are constantly networking with member societies who generate pipelines for different industry and technical careers, as well as focus on alumni associations who may be able to provide career opportunities as the students leave, and specifically maybe for students who want to stay in the area. Also, there was some feeling of discouragement, at least in international populations, between the language barrier and that creating difficulty in knowledge base, and I guess how people understood the knowledge base between the 2 populations. So I believe I've quickly covered everything, and Leela, I can transfer it over to you.
Okay, great. Thanks, Maureen. And thanks for moderating that webinar discussion group. That's great. Now we're going to go ahead and talk about working group number 2. And we had some similar comments come out, some similar themes for question 1. Retention of geoscience students. Definitely our participants stress that including the outdoor component as a unique factor, let's say, in the geosciences, because you're not behind a desk all the time. So stressing that outdoor component to not only education but also the career path. Another thing that was mentioned was we definitely need to see a link made between what the students are learning and how it applies to a geoscience career. And also another way to retain geoscience students that was suggested was to get students involved not only in research projects but also in internships, get them involved with mentors, and also that it's important to build industry academic linkages so that students understand not only how what they are learning is linked to what they can apply in a geoscience career, but also they can start building those relationships with geoscience professionals on a mentor basis. Also, it gives them some industry exposure, it gives them an experience, and helps them get an idea of a career path that they might be interested in. And really those topics really flowed into question number 2, the answers to that, which was pretty much the same thing, but with also an including professional societies in that mix, as getting students involved in professional societies and using professional societies to help them transition into geoscience occupations. So that's about what we covered in our working group. So I'd like to go ahead and thank Maureen Moses again for moderating today's working group number 1. And I'd also like to thank our co-sponsors, Soil Science Society of America, the S Network U.S. National Chapter, and the Australian Institute of Geoscientists for promoting this event. I know we had some really great discussions today, so if you have any follow-on questions or comments, please go ahead and send them to me at workforce@agiweb.org. We will be posting today's webinar on the AGI webinar site here listed at the bottom of the slide. And you can visit this website to view this webinar as well as previous ones that we have hosted and upcoming ones on our webinar schedule. Also, just to let you know, since we registered this roundtable with the Obama administration's Roundtables with Young Americans initiative, we will be writing a summary of this session, and we'll submit that to the administration's youth team along with the contact information of those, for those of you who specified when you registered that you wanted to be listed as an attendee of this event. So if you didn't specify your contact information but you want us to include it in that final report, please go ahead and send me your name, address, and email address here to workforce@agiweb.org. Thank you everyone for attending today's webinar roundtable. Really appreciate your input and all the great discussions. And this concludes our webinar for today.